Hello everyone, I welcome you all in this exciting video. We are looking at some questions in science paper 1 and over section B. We'll start with question number B7. Question here is very simple. Draw the magnetic field lines resulting from the poles of the magnet shown in figure B7.1. And the next question says give two properties of magnetic field lines. And question B says state two effects of the poles of a magnet have on the poles of other magnets. Nice and easy questions. So we have an iron soft bar which has been magnetized and it has developed poles here. We have the north as well as the south pole. So our job was just here to show the magnetic field lines. Okay, so magnetic field lines, they have properties that we're going to state here. Number one, they move from what? North to south. So that's the first property that we're going to state, and here you just show them like this. Okay, say this was a field line. The arrow should always go from north to the south. Okay, so it is always north to the south. Okay, just like that. Okay, in here. Okay, north to south. Okay, so just like this, that's how you can show the magnetic field lines. State true properties of magnetic field lines. Okay, there are two properties that these magnetic field lines that they all have. Okay, they have these properties. Okay, so the first property, number one, is that they do not intersect. Okay, these properties do not intersect. Okay, so I'm going to put this one here. What I mean by not intersecting is that when you have you're drawing your magnetic field lines, okay, in case you have something like this, and this is your north and this is your south. What we mean that, so if you're showing a magnetic field line like this, you cannot come up and just show another one like that. So they do not form these intersections. Okay, they do not form intersections. Okay, all right, so they do not intersect. Then the other one is that I stated it. I said they are drawn from north to south. Okay, so they move from north to south. Okay, so that is the other answer that we have here. So they okay, they do not intersect. They are drawn from north to what? To south. Okay, they are drawn from north to south. State two effects the poles have on the poles of another magnet. What this simply means is whenever you bring, okay, whenever you bring two poles, okay, whenever you bring two poles of a magnet together, okay, whenever you bring two poles of a magnet together, what will happen? So there are only two things that will happen here. Okay, if the poles are like, you can say like poles attract. Okay, if the poles are like, you're going to say like poles attract. And then if the poles are unlike, they are going to unlike poles. Okay, unlike poles, unlike poles attract. Okay, unlike poles attract. Okay, unlike poles attract, let me edit the first one so correct. So like poles actually do not attract, but they they repel. Okay, so this is what happens. So state 2 effects pores have of a magnet on pores of other magnets. So what we are talking about here is that like pores attract. So when you've got north and north, okay, let's say this is north, and also this side here you've got what, north. So the pores here, what basically happen is that these pores will repel. Okay, they'll come out like that, so they'll be repelling. Okay, since they are like, so the same thing will happen if it's south and south. But if the pores are unlike, you have something like this. Okay, and here you have something like this. That is when there will be that attraction. But remember, the magnetic field lines are drawn from north to south. So this was all on this question. We can move to the next question. Okay, so the next question was B8, which was on the cathode ray oscilloscope. The cathode ray oscilloscope, okay, is an interesting question. Name the parts labeled A and B. So first of all, what is the cathode ray oscilloscope? So the cathode ray oscilloscope, it has the name cathode and the ray here, and then it has the word oscilloscope here. So it has to do with cathodes. Okay, so now what happens, what you are seeing here, this is connected to a voltage. Okay, this is actually connected to a voltage, and then there is a filament here, and this filament here is heating up this is now a cathode ray that is inside here. Then the question here says, what is A? Okay, what is what A? So A, the best answer we can give for A is that it is a grid. Okay, A is the grid. Okay, it is actually a grid. So after the cathodes, the electrons are emitted. There is a beam of electrons here. So the cathode was heated. So this is the cathode here where it's heated by the filament. So there's a filament inside here. Okay, so it heats up. Okay, it's going to heat up the cathode. Okay, and then this cathode is going to emit electrons. So these are a beam of electrons. So they have to pass through a grid here, which just makes them to flow in a straight line. As you can see here, they do not go either way, so they'll pass through in a fine line. Okay, and then they are pulled by the cathodes here. So B, these are actually anodes. Okay, that's those anodes. Okay, that is the anodes. Okay. Okay, say this. State the function of the part labeled C. So you have plates here. You have these plates and these other plates here. So now the plates that you can see, you have plates that are like this. Okay, and like this, allowing the beam to pass like this. So they control deflection in the vertical axis. So the ones that controls deflection in the vertical axis, they are known as the Y plates. Okay, we call them the Y plates. So these are the Y plates. Then these control deflection horizontally, or therefore horizontal deflection. Okay, so the function here. These are Y plates, and what's the function? Y plates for vertical deflection. Therefore, vertical deflection. So simple as that. That's the answer. Okay, so for D, these are X plates. Okay, these are X plates, and what do they function? They are for horizontal deflection. Question C, state how the electrons are produced. So let me explain how this is happening. So this is connected to a voltage. So the voltage is going to heat up there's a filament there. Okay, there's a filament. So this filament gets heated up, and then the cathode emits electrons, they pass through the grid, then they're accelerated by the anode, and then here they'll be deflected vertically, horizontally, and then they form. So now here we just want to state how the electrons are produced. So what we're going to say is the voltage heats up the filament. Okay. The heated filament, it's up the cathode. Okay, the cathode. The cathode then the cathode emits electrons by thermionic emission. So that's the process, it's called thermionic emission. So this is what basically is happening here. Okay, this is what is happening here. So the voltage heats up the filament. Filament is heated up, which heats up the cathode. Once the cathode is heated up, it emits electrons by thermionic what? Emission. Okay, nice and easy questions. So let me know if you have any questions on the comment section, and please do like and share the video. See you in our next video.